My name is Alyssa Vishnik. I am the CEO and co-founder at YLabs, and today I am super excited to work through a workshop on LLM evaluation. Specifically, we're going to be talking about evaluating LLMs for performance and quality. And during this workshop, we're going to both discuss different ways of evaluating LLMs and talk about actual kind of applied ways to experience various metrics that we'll be discussing. So if you want to do a quick setup, a handful of links here, you can start with checking out an open source library called Linkit. That's the library we're going to be discussing a lot to give you examples of what some of the evaluation metric that we'll be discussing will look like. And then you can also really quickly get a head start on opening a notebook that shows how to use this library with LLMs. But if you just want to kind of sit back and listen in, that's also an option. Send me your questions. I'm listening in the chat. I want to make this super interactive and really excited. Okay, so quick intro about me. Like I said, Alyssa Vishnik. In the past, I was an engineer, a TPM. I spent many years at Amazon and at the Allen Institute for AI. And I'm a really big MLOps nerd. I've been mainly focused on various types of ML tooling and ML AI tooling, specifically tooling for production systems for the past decade, maybe even a little more than that. And outside of work, I love to travel. I play Beat Saber. That's my way to work out. And I have 2 kids under 3. So if you hear any screaming, that's probably my daughter. She's exercising her vocal cords. So like I said, I'm a big ML ops nerd, and I love talking about evaluation, monitoring, observability, metrics, everything that helps us run machine learning and AI applications in production in a responsible way. So if you're also passionate about it, get in touch. Let's connect on LinkedIn, Twitter, send me an email. I am always excited to chat with people who share my passion about responsible AI adoption through tooling. I'm already getting some messages on chat about you. Please don't be shy. Tell us as I go through the workshop, share with the audience and tell us what are you building with LLMs? What types of models are you using? And ask questions. Let's make it super conversational. This workshop is going to be a little bit different than previous ones because we are going to talk kind of conceptually a lot about metrics and how to develop an intuition about what's possible. So please send me feedback. I would love to kind of address once I run this through. This is the first time we're running this workshop. Once I run this through and get your feedback, I would love to iterate. I'm sure as you develop this intuition about what metrics is possible with LLMs or what type of metrics techniques we considered, you will probably have more and better ideas. So please send me your feedback. All right, if you haven't started setting up, here are the setup links again. So you can sign up for a free YLabs account to visualize the Linkit metrics that we will be discussing throughout this workshop. Then there's the Linkit repo, which is a GitHub repository. Linkit is open source. Thank you for having links also shared here in chat so you can click them easily. So Linkit is open source. You can check it out, give us a star. There's, open source work as a labor of love, and any feedback and support counts big time. So let us know if you have any feedback, open issues, give us stars, etc. Another link that is shared is the notebook, and we're going to be going through the notebook in the very end, very briefly, but you can get started on it. It's not particularly long. You can get through the first section. If you want to go through Hugging Face, also might be fun, but mainly I'll be focusing on kind of the basics today of Linkit. All right, so you're probably all set up. Let's dive in. So evaluating LLMs for quality and performance. Let that sink in a minute. Oh wow. Uh, I'll take a sip of water so I slow down a little bit. I'm too excited. So um, think for a second. The last time you were evaluating an LLM response, how were you doing that? What technique were you doing? Were you using? Were you just looking at the response and trying to judge it? Were you using any kind of metric? Were you using any kind of tool to do that? Because so far, it's a very early and kind of a fast developing field. LLMs are not evaluated the same way as traditional models are evaluated. Well, they can be with a collection of ground truth and computational performance. But because the responses are natural language and are very complex, it is very, very difficult to evaluate with ground truth because it's difficult to collect ground truth. So evaluating LLMs has been a topic of a lot of discussions, and there's a lot of confusion, there's a lot of innovation, there's a lot of discussion of how to do it. So I'm excited to kind of dive into it and unpack and peel the onion a little bit with you. But if you are just eyeballing when you're evaluating LLMs, don't worry, you're not alone, because the most popular way to evaluate LLMs is just looking at the responses and thinking, okay, how good are they? Maybe you're going to look at the responses and judge how complete they are, or how factually correct they are, or how correctly formatted they are. But more or less, that process involves a human looking at the responses and making some kind of judgment. The challenge with this approach is, of course, you'll get exhausted after about 10, 20 such responses that you're eyeballing. And it's fairly expensive because you can only process, I don't know, for very complex ones, probably one a minute. Or maybe if you're really skilled, you could process a few a minute. So it's pretty expensive. And it doesn't really work because when you're eyeballing, depending on your mood and how much sleep you got, you will have a very different kind of sense of how good those responses. So this method, while it's kind of the easiest one to go with, it is not a good one to use. So it will probably make you cry very fast. And our job here and our goal here is to identify alternatives. So I see Dino commenting with Rouge. Great one, much better than eyeballing. Thank you for bringing it up, and we'll definitely talk about it. And Rouge is actually available as one of the metrics that the holistic evaluation for a large language model benchmark features. So if you're not familiar with Helm, it's an effort that is spearheaded by Stanford. I am loading the tab. Come on, Helm. Wow, for some reason their website is down. That's interesting. But if you Google it, it's a really quick search. So it's maintained by Stanford CRFM, and essentially what it is, it's a collection of both data sets and metrics, best practice metrics. I think there are about 160 different metrics that are tracked, and the kind of the value proposition is the data sets help you describe the data sets help you kind of describe the tasks. So there are Q&A data sets, summarization data sets, and they're all ground truth. So there are experiments that were set up, and ground truth has been collected, and you can run your LLM responses, or essentially every LLM is benchmarked, which is available on Helm, against these data sets, and you kind of see the benchmarks of how they perform in these specific tasks. And Helm is great because you can get a really quick sense of how different the performance is across various range of metrics of the popular LLMs, but you can't really run it on your very specific use case. So Helm is mainly you get a sense benchmark-wise how the model is doing. Am I not sharing my screen? Hold on. I am sharing my screen. Max, if you can't see my screen, or maybe somebody else can comment. If you can't see my screen, that's problematic because this is the main thing that I'm sharing. Kelsey, if you're here, would love your feedback if you can't see my screen. Excellent. Thank you, Maximo. You can see it. Okay, Max, then there's an issue on your side, so hopefully that will get resolved. There's a little bit of a delay. I'm not sharing the Helm website because right now the Helm website is not loading for me, so maybe that's the confusion. All right, so hopefully you're able to check out Helm. I would say that is a very important best practice to incorporate into your judgment and evaluation of LLMs. And it's a very easy one to essentially go and check the benchmarks for the specific models that you're evaluating, but it does not specialize to your task. So if you have, for example, a chatbot on your company's website and you're trying to evaluate how good this chatbot is, you wouldn't be able to get benefit from Helm. You'll be able to see how the LLM was performing on various Q&A tasks that are academic, but you wouldn't be able to specifically judge how it generalizes to your data. And it could be a little bit difficult to set up. So now there's a third method, which is called LLM as a judge, which is coined by a paper that was published by kind of a big team of researchers. I'm going to see if I can actually show you the paper. There you go. So there's a quick delay, but you'll be able to see it. If you haven't seen the paper, highly recommend it because it discusses an approach that is very, very popular today in all kinds of open source libraries that uses LLM as a judge. And basically what that means is that once you receive a response from your LLM, there's a kind of a secondary call to an LLM, same LLM or different LLM that's been made, where you construct a question, an evaluation question to evaluate the response. And this team here ran a range of benchmarks on kind of in which cases this technique is good to use, in which cases maybe not so good. The amazing part is that they achieved 80% agreement across evaluations, which is very similar to humans. So it's amazing, but it does have some gotchas. So make sure you take a look at the paper, but we'll discuss this technique at length in the next slide. So just to recap, these are kind of the three most common things that I hear when I discuss how to evaluate LLMs with people. Now, this is not very much, and all of these techniques are kind of subpar, or all of these approaches are subpar. So if we are trying to solve a problem of continuously monitoring your LLM responses or evaluating a wide range of LLMs on a wide range of tasks, these are not suitable. So we at YLabs spent a lot of time thinking about this problem, and we came up with kind of a taxonomy that involves different techniques. So we started working backwards from the questions of what metrics do we need, and what do we want to measure, and how do we want to measure. And the questions we asked ourselves and our customers are around what metrics theoretically can be extracted from text and metadata, which is what LLM responses are, or code in some cases. And then we spent a lot of time thinking about what metrics can be helpful in the root cause analysis of LLM performance or quality of responses, and then what metrics are helpful in root cause analysis of LLM issues. So for example, you're seeing an increase of customer complaints about your chatbot. How do you debug that? How do you debug that issue? What kind of metrics can be helpful? And then the final question we asked ourselves is what metrics are possible to extract in kind of a cost and latency constraint. So after spending a lot of time thinking about it and talking with a range of customers, we came up with 7 techniques for extracting metrics. So keep in mind, this is not the metrics themselves, but rather a different type of taxonomy, a taxonomy that helps you wrap your mind about different techniques that could be used to extract metrics. And each of these techniques can extract a wide range of different metrics. And you will quickly see that there are already two that we kind of touched on. The LLM as a judge is one of these techniques. And then human in the loop, which is on the bottom row, is basically what Helm uses. I mean, it's basically what you're doing when you're eyeballing. You're essentially involving a human to evaluate the quality of the response. But there are specific gotchas connected to both of them, and there are a lot of other techniques in between that we've identified. Now, an important caveat is we currently have 7 techniques, but it's a fast developing field, and I'm sure we're going to be discovering new clever ways of extracting metrics. So I encourage you to give us feedback if you have an approach that you use to extract metrics that's not listed here. Please, please, please let me know. I hope we can come up with a much bigger list here. And I hope we can kind of continue growing and developing this collection of techniques, as well as the actual implementations of metrics that use these techniques, and move forward the state of the art of how to do LLM evaluation. All right, so now let's really quickly talk about, if there's 7 different techniques and potentially this list is growing. If we were to think about comparing them to each other, like how do you decide which technique is the best in which circumstances, etc. So to kind of help navigate this taxonomy, we developed a rubric of essentially 6 dimensions that help us compare these techniques to each other. And the first dimension is cost. So how much would it cost, or how much infrastructure would you need, or how much kind of engineering time would you need to set up each metric extraction using this technique? And kind of the bad side of the rubric is high cost, and the good side of the rubric is low cost. Next one is latency. So how much latency is it going to add to your kind of LLM evaluation process? Maybe you're doing it inline, maybe you're doing it asynchronously. So high latency is bad, of course, low latency is good. Next is setup. So different techniques will require a different amount of setup. Of course, we want to kind of judge how much setup it will require and how generalizable this setup is. So the bad is around weeks, or maybe sometimes in months, and the good, of course, is hours or hopefully even minutes. The next one is explainability. So how easy it is to explain what this metric means. And the bad side of this rubric and spectrum is impossible. So when it comes to explainability of LLM responses, of course, you can ask the LLM, for example, to explain why it judged a certain piece of text in a certain way, but the reliability of that and kind of it's a hallucinated explanation. So the amount of trust that you put on that is comparable. And as far as explainability of the actual technique, like what information went into composing this answer from LLM, that's nearly impossible. And the good side of this rubric is if the explanation is very simple and accessible to non-technical users, that will get a good rating. Now, the reproducibility side. How reproducible is this metric? So if you process a particular response or a prompt through this technique to extract the metric, if you do it today and tomorrow and the day after tomorrow for the same response, would you get the same metric or not? So here again, the bad side is it's impossible to reproduce, and the good side is reproducibility is automatic. So every time it's very deterministic. Every time you process the response and get a metric, it will be the same metric. And the last one is coverage. So because these are techniques rather than specific metrics, how many different metrics can you kind of get out of this technique, or how many different signals and insights can you get from this technique? And probably coverage is kind of the hardest one to wrap your mind around. I'd love if anybody has feedback on better naming for this. And again, Bad coverage is when you can only extract a few metrics, and good coverage is when you can extract any metrics. So now with that rubric in mind, let's go over all 7 of the techniques that we've identified and talk about how they compare and what are some of the gotchas. All right. So the first one we're going to start with is LLM as a judge, and we already touched on that very briefly. So the technique itself essentially involves using the same or different LLM, and you construct a prompt with a score rubric and some examples, and then you generate a score, which involves calling the LLM and essentially asking the LLM on the prompt, what's the completeness of this explanation, or what is the toxicity of this body of text, and so on. And then optionally, you can also ask for an explanation of the score. So that tends to be helpful, especially if you have an LM that could give sources or examples, etc. So that's the setup. A few things that stand out right away is that this is a very, very generalizable technique. So you can pretty much give it any task. This technique is as great as LLMs are because you're asking the LLM. So you can measure everything from factualness to toxicity to presence of topics, etc., to even the compliance with your company policy. You can have very complex tasks, but it comes with quite a few gotchas. First of all, the quality of the score that your LLM will hallucinate or generate is going to be highly dependent on the quality of the rubric that you put forward in the prompt and the examples that you add. So you can't just generate a prompt saying, how factual is this without any context? Like give me an answer between 0 and 1 of how factual this paragraph is. Of course, you will get an answer between 0 and 1 because it's an LLM, but the quality of that answer is going to be very low if you do not give it context of what factual actually means and how to judge it, and what does 0 mean and what does 1 mean. The second gotcha is if you're using the same technique, the same LLM for judging the response, it will have the same weaknesses for your specific tasks. So if you're observing that the LLM, the kind of off-the-shelf LLM that you're using, has weaknesses around the specific task that you're trying to use in the application, keep in mind that the metric will likely have the same weaknesses and will be unreliable. Now, how do we think about this technique in terms of our rubric? So here, I really love these little spider web plots because visually it gives you a good understanding of kind of what is this, how does this technique kind of rank? And just to remind you about a rubric, so the bigger the spider webs, the better. So 5 is good and 1 is bad on this rubric. So keep that in mind. And here, let's call out the pros and cons. So really quickly, you can see that the coverage, as we already discussed, of this technique is great. You can pretty much generate any measure to judge quality. And this technique is probably better than any other technique that we have at hand, aside from human judgment, because most tasks, a lot of tasks are really, really hard to measure otherwise. Now, the technique has a pretty good setup rating because if you're using the same LLM, mainly you're concerned with setting up the correct prompt and rubric. And then this technique can generate explanations for the score with kind of take it with a grain of salt. Those explanations are also generated by the LLM. Maybe you'll have to measure the quality of the explanations using another LM, and then off you go into Inception. Now, the cons of this technique are mainly the fact that you're going to be incurring an additional LLM call for every metric. So if you want to judge factualness, you're going to incur a call. If you want to judge completeness you're going to incur the call. And the latency of that call is going to be, of course, the latency of the LLM that you're using, and the cost will be as follow the same. So the same cost per token as the LM that you're using. That's a big gotcha. So it's really nice coverage of the metric, fairly easy to set up, but has very high cost and very high latency. And then the other cons have to do with the gotchas that we already discussed. Mainly the fact that the quality of the metric will depend on the quality of the prompt that you put together, and then the reproducibility of the scores is another thing that's really lacking. So if you're using like a GPT-4 API, LLMs are non-deterministic by design, and there are changes that are happening behind the scenes to the GPT-4 API. So the judgment or the metric that you will get from a particular body of text, let's say you're trying to score a paragraph for how factually correct it is, if you score it today versus tomorrow versus day after tomorrow, you will have discrepancy in the scores. So that's something to keep in mind. All right, hopefully we got some intuition to start. And this metric we already talked about quite a bit. I think it's probably the most well-known one. Let's talk about others that are potentially less well-known and less widely used. So the second one I want to highlight is using a machine learning model as a judge. So here you're using maybe an NLP model or classification model. Typically, it's something like topic extraction or sentiment analysis or toxicity grading and so on. So this involves identifying and setting up a model that can score the text for a specific metric. So toxicity is a good example. There's a really cool model that's available on Hugging Face, for example, that grades toxicity. And what you can do is essentially pass the body of text and receive a toxicity score between 0 and 1. Very convenient. So if you identify a model and you set it up, you get a few benefits from this technique, which are, the fact that you can set it up fairly quickly, and it doesn't have quite the same kind of error ranges, cost, and latency as the LLM model. So here you're just using a simpler, more lightweight, most likely NLP model. And if you already, one thing I actually forgot in the last metric, if you're already running Linkit, you can actually try these metrics. Try computing metrics with these techniques as we go using Linkit. So if you want to try out LLM as a judge, there are two metrics that are available in Linkit. There's response hallucination that's available, and proactive injection detection. When I give you the walkthrough through the Colab notebook, I will kind of double click on those. But if you are already navigating through Linkit documentation and through the notebook, if you already ran the notebook and extract a bunch of Linkit metrics, you can take a look and see if you can identify the ones that are either response hallucination or proactive injection detection. Now, if you want to try the ML models, the judge technique, the two examples that are available in Linkit, kind of easily available, are toxicity and sentiment. And toxicity uses a Hugging Face model, open source Hugging Face model, and sentiment uses the NLTK model. Now, this technique is great because it doesn't involve making potentially expensive calls to an LLM, but it does have a few gotchas. And specifically, the gotchas are the quality of the metric that you extract, of course, is going to depend on the quality of the model and how well it generalizes to your data. So let's go back to that Hugging Face toxicity model. It's great. It's off the shelf. You can use it today, but do pay attention to what data was trained on and how well that data will generalize to your specific task. And the second gotcha is, if there's no open source model that exists that you can use, then the technique will be difficult to set up because you will have to potentially train your own open source model and so on. Now, let's see how this technique compares on our rubric. So there's some really good things that are going for this technique. First of all, it will have low cost and low latency. And cost and latency in this case is how expensive and how much latency it's going to incur per each call. So you want to extract toxicity from a body of text. What's the cost and latency of that going to be? And in this case, it's a call to the model. So this could be very low cost and very low latency. In fact, this metric could be used inline, synchronously with kind of guardrailing, for example, your LLM responses. Second is if there are open source models for the specific metric that you want to extract, like sentiment or toxicity, then the setup is a breeze. It's very easy and very quickly to set up. In fact, if you're using Linkit for toxicity sentiment, we've already set this up. You don't even need to worry. We get all the models downloaded and set up and ready for you to try. And another really important aspect of this technique is that it can cover a wide range of use cases. So machine learning models are able to perform all types of tasks. So essentially the types of metric that you can extract from a response can range from everything like entity extraction, topic extraction, all the way to, again, toxicity, sentiment, etc. So really good coverage, but not as good as, of course, as LLMs a judge, because machine learning models can't quite perform very complex tasks, like, for example, evaluating factualness and kind of an open-ended manner. And then the cons of this technique, of course, is depending on the type of a model you're using, it could have low explainability. You can always kind of extract feature importance from the model that you're using, but depending on how complex you want to go, sometimes explainability is too expensive to generate per call. If you're using deep learning models. And then if there's not an open source model that exists, it will be a pain to set up. All right. Wow, time is flying. It's already 10:37. I have so many more things to cover. Okay, so let's move on to number 3. We're almost halfway there. Number 3 is using embedding as a source of metric. So basically the way you set this up is you take the embedding, which maybe is available from the LLM that you're using, or you can use an open source embedding. And Linkit, by default, we use BERT embeddings. And you can embed, the prompt or the response that you're measuring, and then you can measure the distances. The most common implementations is prompt response relevance. So in Linkit, you can generate the metric called relevance to prompt, and then you can another kind of very common approach is to measure distance to specific themes. So it could be like a legal theme or medical theme, and you can embed the response and see how close it is to like a legal theme or a medical theme. For example, if you want to identify whether model responses are talking about medical issues or legal issues for liability reasons. I see a question from Max. Yes, Max, I am still aspiring to do a quick demo in the very end, but I'm going to run through these quickly, and we'll probably do a quick demo of Linkit in the last 5-7 minutes of the workshop. All right, so back to embedding as a source. What can you measure with this technique? Well, mainly relevance and consistency are most common use cases, but you can also use embeddings on models trained on, let's say, of models that are trained on undesirable content, and then compute the distance between your body of text, your response, or your prompt, and the undesirable category. So their embeddings are both very versatile, but also if you are just limited to the embedding of the embedding that your LLM surfaces, then you mainly can calculate prompt response relevance or consistency or kind of similarity across a range of responses. And the main gotcha here is if your model if the LLM that you're using does not make the embeddings available, you can always go with an open source alternative. But do keep in mind what was the data that went into training those embeddings, and how does that compare to the task at hand. Most importantly, I think the main gotcha here is oftentimes If the tasks, if the responses are not in English, for example, the embeddings are not going to work really well. So that's something to keep in mind. Now, how does the embedding kind of rate on our scale and our rubric? Well, here, of course, you can see that the coverage is very low. That is one key thing about the embedding, using embedding as a source, as a technique. But it has low cost and low latency. So again, could be used inline. And the setup could be super easy if the LM already exposes embeddings. And it generally has pretty good reproducibility and explainability, caveated with if you understand how the embeddings work. So, of course, explainability is kind of bounded by the fact that the person who's trying to explain this metric understands how the embedding works. All right, let's move on to technique number 4. So this involves computing NLP metrics. And the most popular way of doing this is using something like TextStat to compute the desired metrics. Some of the examples, popular examples of what TextStat computes, and that comes very handy when you're evaluating LLMs, is the Fleisch reading ease score, capturing the difficult words in your responses, or counting words, or you can count sentences, you can count characters, etc. So there is a wide variety of text quality metrics that are available in TextStat, and the in addition to the quality metrics, there are also metrics that kind of measure the length of your prompt or your response, which is also very useful to monitor, because if you suddenly see the prompts that your users are sending ever increasing, that's already a great insight of potentially kind of your users completely changing how they're using your application, or maybe a risk of being jailbroken or prompt injected, or kind of LLM equivalent of DDoS. So again, very handy. And the main gotcha of this TextStat library is, while it extracts a wide range of metrics, everything is designed for the English language, for the English text. So if you're using any other language, it would not work as well. Now let's look at how NLP metrics kind of grade on our rubric. And here again, you will see that it has very low cost and very low latency, so it can be used inline, and it has a very straightforward setup. So basically, you just install TextStat, or if you want to run super quickly, you can just use the TextStat module in Linkit. I will show you really quick what that looks like. And then this NLP metrics has really good reproducibility and really good explainability. So completely deterministic, all of the TextStat metric is. And also, while some of these scores, like the reading ease or reading grade, could be a little confusing at first, but there are explanations and academic research on them, so it's very easy to develop an intuition and be able to explain them. The one problem with this technique is that it has low coverage, so you're very limited to very heuristic metric counts. Okay, technique number 5, pattern recognition. That's a very straightforward one. So how do you use it? Well, you collect the patterns that you're looking to recognize or prevent. Very common use case for this is recognizing PII. So you identify everything that you would classify as PII. Let's say things like credit card number, phone number, social security, and so on. You specify the regular expressions for these, and then you'll be able to scan the prompts and responses to through the regular expression recognizer, and basically identify whether there are items of credit card number, phone number, etc. And if you want to try Linkit, you should look for the module that's called has patterns, because that allows you to essentially specify regexes, and it already comes preloaded with a bunch of PII regexes. A few gotchas of this technique are the fact that you have to think of the patterns that you want to identify in your data ahead of time. and they have to be defined and maintained and updated. And then it is somewhat difficult to extend to new geographies because a lot of PII patterns are very country specific. So while credit card number is more or less widely recognized across the world, things like social security are very, very local to the US. So if you are maintaining an application that's global, you have to think about all of the kind of instances of PII across all of the countries that you're supporting. All right. And how does this compare in a rubric? Well, again, you'll quickly see that this technique, of course, has very low cost and low latency. So it could be run inline. I mean, regexes are really good. You can run them super fast. Again, has really good reproducibility and explainability. Completely deterministic technique. And you can always explain why a particular pattern matches a regular expression. The issues with this technique is that it has fairly low coverage, so you can only find and measure the presence of predefined patterns. And the second issue with this technique is that it is somewhat difficult to set up because you have to think of all the patterns that you want to recognize. Again, if you are trying Linkit, we have it pre-populated with a bunch of regexes that are specific to popular US PII data. All right, number 6, we have 2 more to go and very little time. All right, so end user in the loop. This is a very interesting one. In fact, this is my favorite. So what this involves is building in feedback mechanisms directly into your UI. So if you are a ChatGPT user, you already know that there's a refresh button, there's thumbs up button and thumbs down button. So tracking this metrics is really, really cool and very telling of how the user likes or dislikes the responses that your LLM application generates. And if you want to track this metric with Linkit, essentially Linkit allows you to track any custom metric. So you can define something like thumbs up or distance to edit. So if you have a kind of UI experience where the user types in a body of text and then clicks a button and the LLM, for example, summarizes it or extracts bullet points or something, you can also measure the distance to edit between every time user kind of changes the prompt or changes that body of text. You can see whether there's a big distance or a small distance before the user kind of accepts the response. That's also very telling of how well your LLM is performing. So the few gotchas here are, well, the fact that you have to specifically design the UI to collect this metrics, and that this metrics has to be brought from the UI to the ML and engineering team who's working on the LLM feature, which is something I find among our customers kind of tricky to do because UI is typically super disconnected from the actual ML process. But if you are able to do it, this metric is really, really powerful because it is the closest metric to the actual end user experience. And there is nobody who can judge better how well your LLM application works besides your users. Now, there are a few kind of aspects to how good this metrics is. So let's look at the rubric again. So first of all, kind of the spider web is not very big despite of this metric being really, really awesome. And the reason for that is this measures things indirectly. So you're not asking your user, I mean, you can, but it's kind of annoying to ask your user, you know, how factual is this response or how useful is this response, and kind of require your user to grade it every time they see a response. So you will basically, if you're just measuring thumbs up and thumbs down, you'll get kind of indirect signal. And then this metric has fairly high coverage because you can design a task to collect the most important metrics, and then it will be highly correlated with your performance. Although you can't just ask your user to, you know, well, and maybe you can ask your user to do the most complex grading, like review all of the references provided by the LLM response and, you know, identify the ones that are relevant and the ones that are not. You can design pretty complex asks to your user, but typically this metric captures things like thumbs up, thumbs down, refresh, etc. Now, on the con side, it does require design and engineering resources, and the metrics that are extracted this way, keep in mind, will be an indirect measurement and will lack explainability because, well, I mean, if you're doing this at scale, you can't really go back to your user and ask them to explain why they judge certain thing a certain way. And do keep in mind with this technique, while it's again absolutely great, you will likely not get, unless you're kind of blocking the experience with the request for feedback, you will likely not get this feedback for every single response that your LLM app is generating. All right, and last one, 9 minutes to go, time flies. Human as the judge, which we already touched on, so I'll be really quick. So human as the judge is basically our good old collecting ground truth to then grade how your LLM performs on certain prompts compared to how the human responds to the same prompts. So this basically involves designing a human judging or human labeling experience, identifying the judges. So it could be Mechanical Turk, or it could be using one of the kind of more specialized agencies that identify, very subject matter trained judges, human judges, and then you get the responses from the judges, and you compute metrics such as Rouge, for example. So Rouge is a very common metric to judge the quality of summarization when you have ground truth. And this technique is the ultimate measure of any aspect of LLM quality because it involves designing a very specific experiment to collect very specific feedback on how how LLM responses are comparing to human responses. But if you're judging, well, language is very subjective, and judging quality, completeness, how succinct the language is, how accessible the language is very tricky. So depending on the background of the human that does the judging, you could get very different scores. So it's important to design an experiment where you get multiple judges and you get how agreeing or disagreeing they are. Okay, let's look at the rubric. So again, the pros of this technique is that you can design an experiment to basically measure anything, any aspect, but do keep in mind that you will have to design a very specific experiment for every specific kind of metric that you want to extract. So it has very high coverage, but some of the measures you will be able to design that measure things directly, and some will be kind of indirect measures. And then on the con side, you will have to design an experiment and identify human judges, potentially bring in human experts, etc. So the setup could be very painful. And then it is impossible to judge 100% of your LM responses. So you will also have to decide which responses you want to collect. So keep that in mind. All right, we have now covered all of the 7 techniques, and probably the question on your mind is, how do you choose the right metric and how do you choose the right technique? Well, there are 4 things that I found to be very helpful for questions that I found to be really helpful to answer as you're thinking through this. One is, how critical is this use case? If you are in kind of in the industry of anything related to medical advice, legal advice, some kind of high cost decision making, I would categorize that as critical, and I would identify kind of the most faithful metrics that you could compute and potentially compromise on latency and cost, because you do want to make sure that the LLM responses are high quality and you can identify hallucination, you can identify kind of poor responses, because it's a critical use case. The second thing to think about is, what are you trying to optimize for? So again, are you trying to make sure you do not let through any bad responses and you are going to be scanning things inline? There, you might have to compromise and look for metrics that have very low latency, and that's what you're going to be bounded. So you can only choose the best stuff within the low latency category, or maybe you don't care about latency as much. So then kind of your possibilities open up. And then again, what are your constraints? Do you want to run this synchronously, asynchronously? Do you have cost constraints, etc.? And then finally, who is the target audience for this metric? So if you have non-technical audience that would be looking at this metric, might want to go for things that are more explainable and are easier to kind of wrap your mind around. All right, so here is a really, really quick view of how do the 7 techniques kind of compare across the rubric that we developed. We'll be sharing these slides, but I thought it's a really cool visualization. I'm not going to talk about it because we just have 5 minutes. So now what I'm going to do is I'm going to really quickly run through the demo notebook to make sure that we wrap up round on time. So what I'm going to do, I'm going to skip the YLabs. I'm going to skip the YLabs account for a second, and you can go ahead and create an account. So YLabs basically allows you to run or monitor continuously a range of models completely free. And if you're using Linkit, there's kind of a very easy way to ingest the actual scores that Linkit extracts into the YLabs platform and visualize and build dashboards. But here, we're going to mainly focus on the Colab notebook that is shared. So I think there is a notebook that was the link to the notebook that was already shared in the chat. And here, I'm going to rush through this. It's pretty straightforward, so no need to spend a ton of time. You can essentially run through Linkit and generate a whole bunch of metrics and start building intuition around them and recognizing which techniques which metrics are being calculated with. So we're going to start with just kind of a really, really quick intro to Linkit. So Linkit, as I said, is an open source library. You can check it out on GitHub, and Linkit allows you to extract a wide range of metrics from LLM prompts and responses using basically all of the techniques that we have discussed. The key thing about Linkit is that all of the metric extraction process will be happening in your environment. So you're not sending your prompts and responses somewhere to a third-party provider. And Linkit makes it very, very easy to extract a wide range of kind of off-the-shelf techniques. So you don't need to do any configuration to get a bunch of text quality techniques, which is the NLP quality category. You will get relevance, which is embedding extracted category, so relevance scores. You will get a bunch of security and privacy metrics. Some of them use patterns, so regex patterns, and some of them use embeddings, and some of them use ML models. Prompt injections and jailbreaks use a combination of embeddings and ML models. And then sentiment toxicity both use ML models. So Linkit is super, super easy to get going with. I'm going to really, really quickly run through. So let's get the environment set up. All you need to do is install Linkit. We're also installing transformers because as part of this notebook, you can also try running on an actual Hugging Face model. And while this is installing, I'm going to just really quickly walk you through the very few lines of code that you need to execute to run Linkit. So the first thing you want to do is you want to import Linkit, and there are kind of 2 versions. There's the LLM metrics version that you can use, which brings in all of the out-of-the-box LLM metrics, or you can use light metrics, which is a subset of all the metrics and kind of only gives you the stuff that's fast to run. This is an initialization for later using YLabs platform, but all we need to do is essentially initialize the schema. So that's going to download a bunch of models that Linkit is going to use. So the start might be just a little bit slow here because we'll download a bunch of models that then will be used across our grading. And then all you essentially need to do is um, run your prompts and responses through this line. Here, we're essentially logging chats. And in this case, to kind of make the setup faster, what we are looking for is loading a bunch of chat examples. And then these chats are, a set of prompts and responses. And we run these chats through Linkit. Um, uh, Asking, okay, maybe I should skip the init so I don't have to spend our time here initializing YLabs. All right, so this is all done. Running Linkit really quickly, you will see, so I'm using kind of not the lightweight, but the heavyweight version of Linkit that collects a whole bunch of different metrics from both prompts and responses. So these are sample chats. And we ran, the Linkit through the 50 chats. And basically that allows us to extract the type of a wide range of metrics that we discussed. Because I'm running out of time, I am just really quickly going to show you in the platform when you run Linkit with the default setup, with these default results, what are the actual out-of-the-box metrics that you get and how to kind of make sense of them. And I'm sure you can follow along through the notebook yourself and share with me the kind of the whole process in the chat, in the comments, or in the Slack. So let me quickly bring up a YLabs demo environment. And if you created an account with YLabs in the beginning, you can also navigate to this demo environment by selecting one of the global organizations. And here is an example of a chatbot that is being monitored. So each prompt and response gets processed by Linkit, and we extract a wide range of metric. And here, if you click on Telemetry Explorer, you will be able to see all essentially types of metrics that we've been extracting for this particular chatbot. It's taking a sweet minute to load from both prompts and responses. So really quickly, you can already recognize some of the techniques that we discussed and the metrics that we've extracted using those techniques. So for example, the reading ease of the prompt, that is extracted using the NLP metrics technique. Sentiment, for example, of the prompt, that metric is extracted using an ML model from an LTK. Things like has patterns, for example, is a metric that's extracted using regexes, and so on and so forth. So relevance to prompt is a metric that's extracted using embedding similarity. So if you run through Linkit and then load the results over, so essentially go through this quick notebook, you will be able to see a dashboard in YLabs with all of these examples of metrics that you can extract. So keep in mind that Linkit with the default setup, I'll go back to this notebook. With the default setup, you are essentially extracting all of our out-of-the-box metrics to help you develop an intuition of the types of things that are possible to extract using the techniques that we just discussed. All right, so now I am really running over. I was hoping to spend a lot more time in Linkit and in the demo, but turns out going through these 7 techniques is very time consuming. So I'm going to see if there are questions, and I think there are a few before I wrap this up. So bear with me. Saucy is asking, what is the best evaluation metric to evaluate a QA model with ground truth? I would say a good starting point is Helm, and I'm trying to load their website. They're really down today. I don't know what is happening. Come on, Helm. Let's see. Oh, there you go. Okay. So it finally loaded. So Saucy, I would start with Helm benchmarks to kind of, if you are evaluating a question answering application of the LLM, because in the Helm benchmarks, you can essentially get off the shelf. There's a bunch of Q&A benchmarks that you can take a look at. So here you can compare and contrast different models for these very specific different Q&A tasks, and that doesn't even involve running anything. That's a very good start. So you can quickly see here, there's a bunch of metrics that are already extracted for all of your favorite LLMs. So I'd start with that, and then from there, I would probably look into Linkit, and depending on what you want to measure, depending on what you want to evaluate, get a handful of metrics. I would say the easiest one to try out and to develop intuition with is prompt response relevance, since it's a question answering model. So that's an easy one to start tracking. In addition, you can also track NLP metrics to see how kind of easy and readable and comprehensive their responses are. So I would say those would be my starting points. And then there is the question from Max: what is the linkage or similarity between Python Linkit and the YLabs tools? Great question. So Linkit is an open source library which runs in your perimeter, and Linkit extracts metrics from blobs of text, most commonly prompts and responses. YLabs is a platform that helps you track these scores over time, potentially across different experiments, across different models that you're comparing. And YLabs platform only ingests the scores that are extracted from prompts and responses, doesn't ingest your actual prompt and responses. So all your data is kept safely, and it allows you to essentially build dashboards and configure monitoring to track how these metrics change over time, and kind of what you can recognize in this metric in the prompts and responses. So to give you an example, has patterns is the regex techniques that we were discussing, and here Linkit is configured to detect PII. So we've been monitoring an LLM chatbot over an entire day, looking for instances of PII leakage, so PII in the response. And here in one of the hours, we've recognized that there are 16 responses that contain social security numbers and emails, and 24 responses that contain credit card numbers. So this gives you kind of a quick glance at the fact that you have a problematic instance, problematic episode in your model behavior. And in order to kind of debug it further and get into the raw prompts and responses, one of the things that we support is linking your S3 bucket where your raw prompts and responses are located, which then allows you to go from high level, which is, this is where the issues, this is the hour when we observed the issues, to here are in my S3 bucket, the raw prompts and responses, so you can take a look at the ones that are problematic and were flagged. All right, so now I'm really running over. Max, I would love to connect with you on, so actually, I'll answer your question in a second. As I'm talking about YLabs, one of the things you can do is you can try YLabs completely for free, no strings attached. For those who are joining the workshop, I'm happy to share code that you can use to create an account. So don't be shy, create an account, share with your colleagues, give us feedback. It's, LLM performance and LLM monitoring is a fast developing field. So we'd love for you to try out what we built so far and give us feedback. And lastly, Max, if you want to connect and discuss questions, there's a Slack community. I hang out there. The team behind Linkit hangs out there. So please consider joining. I would love to catch up on all of the questions that I didn't get a chance to answer. We're really running over. So I really appreciate everybody staying a little bit longer with me. Thank you so much for your time. I hope we've been able to develop a bit of an intuition about how to measure LLM performance and quality. I'm looking forward to your feedback. Please don't be a stranger. Get in touch. Connect with me on LinkedIn. Let's connect on Twitter. And Thank you for joining the last workshop of 2023. I hope you have the most amazing holidays with your family and off to 2024 to more breakthroughs with LLMs and more amazing use cases that we can implement to delight our customers. Thank you.